All right, so today I'm going to talk about an interesting subtask of sentiment analysis, target-based sentiment analysis, and Google's recent model T5. So let's dive in. I'm not going to talk about the outline. So before talking about what sentiment is and what T5 is actually, I wanted to introduce that last year Google announced about their new search algorithm, MUM, which is the multitask unified model, and they've changed the BERT to T5. Essentially, two of the models are Google's publications, but they're claiming that it's 1,000 times more powerful than BERT, and since T5 can also generate text, it's more powerful. And also, it's trained across 75 different languages, and it has the potential to overcome the language barrier. And say, for example, when you do your search in English, but the relevant information is in Japanese. For example, you're trying to find something about Mount Fuji, but you won't find lots of information when you do the search in English. It will, through transferring knowledge approaches, go find the information in Japanese and then bring it to you in English. It's also multimodal, and the search is going to work using different kinds of data, text, images, video, audio, and actually not all of this is currently there. They have promised that in 2022, so this year we're going to see all of this happening. So this is to show that T5 is not just a random model. And also I'm going to talk a little bit about data-driven approach or data-centric AI. I have a question. Do you guys know Andrew Ng? Yeah, I assume all of you know Andrew Ng. If you know or you have dealt with ML, you do know him. He's the pioneer of machine learning, and it's his premise that we should switch to data-driven AI rather than model-centric AI. The thing is that when we're trying to do the model-centric AI, is we're holding the data fixed, and iteratively we're improving the model until the desired results are achieved through, and we have to deal with a lot of noise in the data. In this case, we can have a lot of bias coming from, making the model to fit to data. But he suggests rather to keep the model fixed and iteratively improve the quality of the data. And there is this proof of concept to production gap that it's the inability of AI or ML models to do well in when they're already in production because of the low quality data. And not only Andrew, but Google also thinks that data is the most undervalued part of the ML. And this is oops, I'm sorry. This part is their title page. They say that everyone wants to do the model work, not the data work. It's the title page of their recent paper. And the idea is that currently we have so many powerful models through open source repositories or the research is there. So recently companies would struggle to hire, top PhDs, but now any company can have access to codes that for example, Google or NASA can use. It's in the end comes down to data. So why am I talking about this approach? Because when we've tried to solve this task, we also have built it around this approach on quality data. Okay, now regarding the sentiment, why do we need sentiment analysis and what is sentiment analysis? I think all of us know the classic approach to sentiment analysis, which when we try to classify text as positive or negative, and the binary version of it. But actually, we need sentiment analysis pretty much in all the domains: marketing, political campaign companies, management sessions. There was even thing done when they were tried to predict the election results with tweet sentiments. I don't know. So businesses always want to know what their consumers and public thinks about their product, and Also, the consumers need to know what other people are thinking about this or that product. So that is why whenever there is an opinion that we can try to make sense of, the sentiment analysis comes to help. And actually, there are different kinds of sentiment analysis. There is more fine-grained approach when we try to classify also the polarity of sentiment, like it's slightly negative, slightly positive. There is aspect-based sentiment analysis, emotion detection sentiment analysis, intent-based sentiment analysis. The one of our particular interest is the aspect-based sentiment analysis. So let's try to understand what is aspect-based sentiment analysis. Usually, having just a general sentiment of a piece of text or sentence is not enough, because both users and businesses want to know what exactly is bad or good. For example, we can have all these characteristics of a phone or whatever entity it is, and have those to behave as aspects, like the screen, camera, I don't know, the price of the phone, the performance of the phone. And we can have a review where we have all the good things about this phone, but in the end it says battery life is really bad. So the manufacturer needs to understand that in this context we have sentiment where towards all other entities it's positive, but towards battery life it's negative, so that, I don't know, you can do something about this or ignore it, I don't know. And also the consumers need this information. So there's also targeted aspect-based sentiment analysis, where we are, rather than just identifying aspects and their polarities, we also want to identify the target. Let me show you an example. Okay, so let's take a look at this one. It says the Mountain Hill Hotel was good, but the food was really bad. So here we have the mountain, which is an aspect expression of location, and towards it we have a positive sentiment. And then we have aspect expression of food, and towards it we have a negative sentiment. Like the classic sentiment would fail here because it would result in a conflict. We have both negative and positive here. But with the aspect-based one, we can have the fine-grained sentiments toward each aspect. If we make it target aspect-based sentiment, we would also need to identify that those aspects are talking about the entity hotel, for example. Also, there's different levels of sentiment analysis. It can happen document level, sentence level, and entity level. Now I want to talk a little bit about benchmarks. What is there, what research is done, what data sets do we have for sentiment? The SST is Stanford Sentiment Benchmark, and it's labeled parse trees of movie review data sets. The binary version is SST2, and the fine-grained version with 5 labels is referred as SST5, with negative, somewhat negative, neutral, somewhat positive, and positive labels. Then for aspect-based one, we have the semi-val ABSA datasets. It's 2 domain-specific datasets for laptops and restaurants, around 6,000 sentences with their specific aspects. And then for target aspect-based one, we have Sentihood. It's London's neighborhoods dataset, was from Yahoo question answering platform. Some sentences were gathered, and only 1 or 2 the sentences that had 1 or 2 locations were regarded in the task, because when they were more than 2, they did not regard them. And the sentiments should be classified either positive or negative. Okay, now let's look at the leaderboards to see what we have. For the SST2 version, it's pretty much like the most solved task. It's around 100%. The T53B reaches that score, and there are tons of other models that do this. But interesting things happen when we move from binary to more fine-grained version. Like for SST5, the scores drop to 60. And even with Roberta Large plus self-explaining, we have just 60% here. And Roberta Large, I don't know if you're aware, it's actually pretty large. It's around 360 million parameters. Actually, I've also tried to see what T5 can do on SST5, and I've got around 54% of accuracy. But I'm pretty sure if T5 larger models were used, it would have been pretty close to Roberta. For the aspect-based ones, we have around 90% accuracies for both target aspect and aspect. But I want you to notice here that like those benchmarks are a bit broken because the data sets are very limited, constrained, and when we want to solve a real-world problem, we just cannot go ahead and, I don't know, use London neighborhood data set when we want to identify, say, different targets. There are also some linguistic level challenges with sentiment analysis. There can be irony and sarcasm. For example, what a great car. It stopped working in 2 days. Like the grade would say that this is a positive, but of course this is a negative sentiment. Or we can have that like a positive or negative sentiment word may have opposite orientations, like vacuum cleaner really sucks. Sentences that include a negation. This will be his first and last masterpiece. And sentences taken out of context, sentences that like they contain sentiment word that may not express any sentiment. This usually happens with the questions. And one of the hardest ones is that when we have just factual information, and it can also contain sentiment. Like after sleeping on the mattress for 2 days, a valley has formed in the middle. Like no sentiment expressions, but of course this is a negative connotation. And then sentences of ambiguity. I can't recommend this book too highly. Like this is not even a sentence like trying to classify anything. Okay, now I want to present the task of interest. It's targeted sentiment analysis on factual data, where it's a domain-specific data. It can be any article. Like the one I was trying to solve was regarding any person or organization. Any article where there's not much sentimentality expressed, no sentiment lexicon. Why am I stressing this? Because like when we talk about sentiments, we're usually trying to make use of this sentiment lexicon, like very good, very bad. But when it's an article or something more factual, we don't have that. We need to understand the context rather than the emotions or sentiments here. The sentiment had to be classified document level. Positive, negative, and neutral needed to be the labels, and the same entity could have been in different articles. In one place, this person could have had a negative article about it, in another one positive, I don't know. So this is pretty much the task. And I want to talk about the data annotation. Since I've talked about data-centric AI, I want to say that like we spent quite a bit of time on data annotation, and I want to thank our computational linguist Marati Abrumyan, who went and did all of this, and he had all the knowledge required to make really good annotations that don't have any bias. So imagine we have I don't know, some boring text, some boring article, and here we have some targets, different companies or organizations, and their corresponding labels. And we need, this is basically the task, having the targets, identify the targets and the labels towards each target. Like one sentence can contain many targets, or actually it has to be done document level. Why T5? Before T5, we've tried like some other choices. BERT was the for the as a first choice because it's, I don't know, logical to have classification model, and BERT is known to to understand context very well. But it wasn't very good, so we went ahead with T5 because there was this hype about T5 that time, and it was good. I don't know, it turned out to be good. T5 is standing for text-to-text transformer, and it refers to all the tasks as text-to-text tasks. For example, it receives the tasks as a text and outputs a text in the end. It's a generative model. So it's an encoder-decoder model. I'm going to talk a little bit about this later. So what it does to the tasks, it prepends a suffix to the task. For example, when we want to do a summarization, we say summarize, then colon, and then we give the text. Like for sentiment, we do sentiment, colon again. Or for question answering, we say question. There are specific things that need to be used there. So basically, it's a text-to-text format. And the T5 is an encoder-decoder architecture. I don't know if you're familiar with the vanilla transformer. It's pretty much the same thing, uses both encoder and decoder with a little bit of change to the positional encodings. It uses relative positional encodings rather than absolute or some other kinds. There is also some small changes to how the normalization and other small things are done, but the architecture is pretty much the same. It comes, T5 comes with different sizes. We chose the small one because it was small and for inference purposes. Actually, the main component of any kind of transformer is the self-attention layer. Self-attention is like trying, when we have a sequence of text, say a sentence, we represent it as tokens, and in the end we want to have the same, pretty much the same encoding for this sequence, but more contextualized. Like this approach will give you, say in the end each word will attend to all the other words and will know information about them, and we'll make it, not we, but like it's made multi-head because we can have that the same word can attend at the same time to different other words in the same piece of text or, I don't know, sentence. This is the main mechanism of the attention. This is some visualization how, I don't know, each word is connected to the others and their attentions. So actually, recently it has been really well known to pre-train the network on a data-rich task. After that, to do fine-tuning on downstream tasks. So the T5 uses supervised and unsupervised pre-training approaches, and then it's fine-tuned on different tasks. So as an unsupervised objective, it uses mask language modeling approach. It drops 15% of tokens and then tries to, I don't know, generate those tokens back. The belief is that through doing this, it will understand the language constructs, it will understand the context, and in the end, any downstream task can use this information. Okay, so before talking about the results, so what we did with the T5 here, actually T5 was then fine-tuned on SST2, so its sentiment is basically working on SST2, and when we give sentiment, the colon and text will get back a sentiment, but this approach was not really good, again, because of it was like movie review data set, it was not of our interest, the data were totally different. Instead, the question answering approach worked really well, like having a good question asking about the sentiment worked really well here, and then some fine-tuning was done for layer freezing, optimization, I don't know, encoder-decoder freezing, gradient clipping, different learning rate schedulers. I really liked the cosine annealing learning rate and the cosine annealing with worm restarts. So with that in mind, we got, I don't know, some scores around 82, 83%, 82, 83 for F1, for 2 labels. Actually, this is a bit different. We didn't train on 2 labels. The one below, it's 3 labels, negative, positive, and neutral. Then we tried to see sort of concatenate the positive and neutral ones together and create a label for neutral to positive. Maybe if we've trained on just binary classification, it would have been much higher scores. But let's remember that this is just the T5 small. And I think the results are pretty good. It's hard to say that we can compare these two benchmarks because, again, as I've said, they're like totally different things. But still, I think it's pretty good. So actually, for preparing our test data set, again, going back to data-centric approach, we did this manually because we went through the articles. Like, we don't want to have similar articles in the test set, or we don't want to have the same entity in the test set. We need to have it as clean as possible. And this model is now in production. We also get feedback in production. And so far, didn't get any bad emails. Yeah, and also I wanted to talk about a little bit about the prefix. The prefix that I was saying, that you append like sentiment and you give it as a task. This prefix is essentially a hyperparameter that can be fine-tuned. There are prompt engineering approaches for this. The WARP is an Armenian research from Yerevan, and there are also other researches there. And the interesting thing is that like all these research papers came out at the same time. T5 advises. T5 says that in their paper they say like wording doesn't really for the prefix doesn't matter much. That's why they don't do much hyperparameter tuning there. But I don't know, maybe for a specific task it can be really helpful. So that's about it. Thank you. If there are any questions, I'll be happy to.
Thank you for great presentation. I have 2 questions. The first question, did you try maybe use only encoder part of T5 like a bird? I think that decoder part is needless for sentiment analysis and other classification tasks.
Yeah, actually we did try it. Just like BERT, the encoder was not enough. I don't know. It was weird for me that in the end we ended up using a question answering approach.
Accuracy was worse, yes?
Yeah, it was worse. But I also have to say that we went like back and forth through data a lot, because at some point we made our data set bigger and we didn't do the same experiments that we did before having this bigger data set. So maybe on that it could have worked. I cannot say that it's bad. But yeah, the logical thing is to go with an encoder model.
And the second question, did you try some augmentation techniques for text? Something like insertion or deleting, masking tokens during supervised learning?
Actually, no, because we wanted to use the information that was learned there. So we froze the first couple of layers so that we can make use of this learned information. And as I've said, like the data was really well prepared. So if I don't know, since it's a bit different data, I don't think that like augmentation and stuff could have worked. We could have had like, I don't know, the context could have changed or something.
Okay, thank you.
That is why. Yeah. Thanks. Thank you.